Hello, I'm Jovan, and I will present you my work on MXFaaS, resource sharing in serverless environments for parallelism and efficiency. Serverless computing is a popular cloud computing paradigm that brings a lot of benefits for both users and cloud providers. Therefore, all major cloud providers nowadays have serverless offerings. However, our characterization of the environment reveals important insights about the main sources of inefficiencies in serverless computing. First, serverless functions are often invoked with many concurrent invocations. This burst invocation behavior is not handled efficiently by current systems that spawn many concurrent containers to serve individual invocations. On the other hand, serverless functions are dominated by the idle time. They spend a lot of time waiting on the data from remote storage or RPC responses from remote functions. This results in an efficient use of allocated container resources. Third, concurrent server invocations of the serverless function typically access the same data and instructions such as shared libraries or function-specific initialization. Only a small fraction of the memory that is accessed by a single invocation is private for that invocation. This results in significant state replication, which consumes lots of memory. Finally, as concurrent invocations of the same function execute the same code, they should also frequently access the same storage area for the same or similar data. As invocations happen concurrently, the storage is also accessed in bursts with many concurrent requests. This creates bottleneck in network bandwidth and remote storage processors. To address the aforementioned challenges, we propose a new serverless platform design called Multiplex Function as a Service, or MXFaaS. MXFaaS optimizes the execution of serverless functions during bursts of invocations for the same function, with the introduction of a new container abstraction called MX containers. MX containers enable efficient use of resources by multiplexing CPU with smart handler scheduling, multiplexing I/O by coalescing the remote storage accesses, and multiplexing memory and processor state by performing late fork and binding functions to a specific set of cores. MXFaaS delivers high speedups across a variety of applications and system state. On average, across all functions and applications, MXFaaS achieves the average speedup of 5.2 times over a state-of-the-art baseline. To conclude, serverless computing brings a lot of benefits, but its current execution is inefficient. To address the challenges, we propose MXFaaS, a novel serverless execution model based on resource multiplexing. MXFaaS introduces MX containers for sharing CPU cycles, I/O bandwidth, and processor and memory state. MXFaaS achieves high speedups with the average of 5.2 times and reduction in tail latency of 7.4 times, while improving throughput by 4.8 times over a state-of-the-art baseline. Thank you for your attention, and I'm looking forward to full ISCA presentation.